Hey everyone, this is the video for 7.1 and 7.2. The first page of your notes is just practice from chapter 5. It outlines the different methods of finding the greatest common factor and least common multiple. So I just recommend you work through those problems independently. You can pause the video here, and you can also check your answers with the answer key available online. So chapter 7 is extremely important. It's all about linear equations. So first we need to have a pretty solid understanding of what's an expression versus what's an equation. So an expression, the easiest way to define it is it doesn't have an equal sign. It is just a statement, for example, 5 times a number. Now an equation is when we have an equal sign and there's an actual solution or sometimes no solution, and we're going to run into that today as well. So for example, I could say 5 times the number is 10. That would be an example of an equation because I could solve that to find that that certain number we're missing is 2. Now there are some things they have in common. They have variables, which are the different letters in math. They have constants, which are just the numbers. They also have coefficients sometimes, which is the number that comes in front of a variable. So they do have some similarities and they use a lot of the same verbiage. So go ahead and take a second and fill in your vocab terms. All right, once you're done with your vocab, we need to take a look at the many different ways to say the different math operations. So the next part is words that we could use to describe add, subtract, multiply, divide, and equal. There are a lot of different ways that we use these words. So for example, add, the most common we use is sum. We could also say two more than a number, which means we're increasing. Subtract, on the other hand, usually, we can say the word minus or take away, but it could also be reduce, it could be difference. So we have to stop and think what the words are actually telling us to do. For multiply, we could say doubling a number because that means to multiply it by 2, or tripling a number to multiply it by 3. Or sometimes they just use the word times. For divide, that would be finding the quotient. Now, we could say splitting something in half, which would mean to divide by 2. Sometimes they just use the word divide as well. And equal, the most common word we're going to find today is the word is. Whenever we see the word is, it usually means that is where our equal sign is going to go. So if you want to jot down some of those words I just covered, that'd be a great idea, because we're going to take a look at the next section where we're going to see if something is an expression or an equation. We're going to decide which one it is. So I'm going to use EX for expression or EQ for equation. And then we're also going to take the words and write it out with numbers now. We're not going to solve anything because we only can solve equations anyway, but we're just going to interpret these different statements. All right, so let's take a look at expression or equation. So number 1 says the product of a number and 3. So product is actually a word we could add to our vocabulary under multiply. And the phrase of a number means we're going to need to select a variable. In my examples, I've selected n as the variable I'm going to use. So first thing, I'm going to identify this as an expression because it is not telling me that it is equal to something. So the product of a number and 3. So that means to multiply 3 and the number. So math etiquette is that you put the variables first, typically, but if there's a coefficient or you're multiplying, the number should go up front. So it's going to be 3n, which means 3 times n. Number 2 says 8/9 of a number is 56. So the phrase here says is 56, which means it's going to be an equation because it's equaling something. So 8/9 of a number. The word of in math also can mean to multiply. So 8/9 times n equals 56. And the next one, a number decreased by 8. So decrease means we're going to subtract, and it doesn't tell me it equals anything, so it's an expression. So a number decreased by 8 would be n minus 8. So those are some of the basic problems we're going to see, and now we're going to get into the more involved problems, and sometimes we're going to have to work backwards, similar to what we did earlier in the semester. So let's take a look at number 4. If 2 is added to 5 times a number, let's first take a look at this section. So if 2 is added to 5 times a number, 5 times a number would be 5n, and then we add 2 to that. So the first part would be 5n plus 2. It says the result is, which means there's going to be an equal involved, which also helps me go ahead and identify this as an equation. So the result is equal to 3 more than 4 times the number. So when we put this all together, 4 times the number would be 4n, and then 3 more than that would be to add plus 3. So what we're left with is 5n plus 2 equals 4n plus 3. This is an equation that we can go ahead and solve, but for this part, we're just going to go ahead and practice writing them out. All right, so 5 and 6 are a little more difficult. I want you to go ahead and pause the video and give 5, 6, and even 7 a shot. Remember to look for words such as tripled and twice then, and we're going to have to take a look at using some parentheses. So give them a shot and then come back to the video so we can take a look at how to solve these. So let's take a look at number 5. If 4 is subtracted from a number and then this difference is tripled. So this is thinking about order of operations. The first thing we want to happen is to subtract 4 from a number, which would be n minus 4. And then we're going to take that and we're going to triple it, which means to multiply it by 3. So when we write this out, it is an equation, and the 3 would be up front, which would be part of the distributive property, and we've seen that property in previous chapters. So 3 is being multiplied by that entire first section. So number 6 is similar setup. It says if 1 is added to a number and then that sum is tripled, so n plus 1, and that's being tripled, so the 3 is going to go in front as well. And all of these are saying a result, so they're equations. And finally, number 7. So this one had a lot going on. This was by far the most difficult one. So 6 is added to twice a number. That would be what's inside of my parentheses. This is then being multiplied by 3. The result is the same as if the number is multiplied by -10 and 2 is added to that product. All right, we're going to go ahead and move on now to talking about how to solve equations. Hopefully you've checked the videos out that are posted with different YouTube links so you can, take a look at different ways to solve them as well. But we're going to go ahead and move through the next part of the notes. So the first step in solving equations is to stay consistent. Whatever you do to one side, you need to make sure that you do to the other. I prefer to start working on the side that has the smallest variable. Sometimes there's only one variable in problems, and you would just start on the side with the variable. But if there's 2 variables on different sides, that's when you would start with the smallest variable. You're going to do the opposite, adding and subtracting of the constant, and you're going to do the opposite, either multiply or divide, of the coefficient, which is the number in front of the variable. And once again, fractions, to get rid of a fraction, multiply by the reciprocal. So some words we need to know. So most of these you have an understanding. So an equation is a math problem when both sides are the same value. They're equal to each other. A variable is a symbol, which is usually a letter, that represents a number. Constants are the number being added or subtracted from the variable, and the coefficient is the number being multiplied or divided. Finally, the reciprocal is when we turn the fraction upside down. So we're going to use these different steps and apply them to solving some equations. So we're going to take a look at number 1. This is what we would call a 2-step equation. So we're going to solve this one together. So I always start with the side with the variable, which is going to be the left side. A lot of times I like to teach my students to draw a vertical line where the equal is, so they know that what they do to one side of the blue line, they need to do to the other. So first thing I need to do is to eliminate the plus 8. So the inverse of adding 8 is going to be to subtract 8, and what I do to one side, I'm going to do to the other. So on the left, the 8's cancel out, and I'm left with 7x equals 15, take away 8 is 7. So now a lot of you guys already know that the answer is going to be 1. However, to solve this and show our work, to get rid of this times 7 up front, we would divide both sides by 7. So my final answer that I'm going to have would be x equals 7 divided by 7, which is 1. It's really important to organize our work because that's what we're going to show our students to do one day. So I like to keep it neat. I like to circle my final answer and make sure everything is very clear. So number 2, we're going to do the same thing. I'm going to draw a vertical line, and I'm going to start on the side that has the variable, which would be the left as well. This looks a little different, and this really stumps students. They think they need to work with the minus 5z, but that's not true. We need to work with the constant first. So this is a positive 7 up front, so I'm going to subtract 7 from both sides because that's the inverse or the opposite of a positive 7. Now, I cannot forget to bring down that minus sign because a minus symbol is essentially the same thing as a negative. So I have negative 5z equals 17 take away 7 is 10. Now, my final step is to get rid of that coefficient. So to eliminate the times negative 5, I'm going to divide both sides by negative 5. So 10 divided by negative 5, my solution would be z equals negative 2. And once again, we should try to organize our work. I'm going to circle my final answer. Now we're going to get into some more challenging problems. I'm still going to use the same strategies, so I'm going to draw my vertical line. And now I'm going to start with a side that has a smaller variable. Now, technically that's over here on the right, but first thing I need to do on the left is to combine like terms. So what that means is 5x take away 3x, that's on the same side of the vertical line, so I'm going to just do that operation. 5x minus 3x is 2x. And I'm going to bring down the rest. Now, sometimes I use the phrase to pick on the little guy, so I have a 2x on one side and just an x on the other, and we know that there's an imaginary 1 in front of there. So I'm going to pick on the small variable, and I'm going to subtract x from both sides. So 2x take away an x leaves me with just 1x plus 13. And then on the right-hand side, all I have left over now is a 6. So I'm going to bring down the 6. So finally, to isolate my variable, to get the x by itself, I need to take away the 13 because that's the inverse of adding 13. So 6 take away 13. The answer to this problem would be x equals negative 7. All right, we're going to continue practicing solving some equations, and then we're going to move into literal equations as well. This page is entirely for your practice. I just do want to point out a couple things that I know you've seen in previous math classes, is when there is a number in front of the parentheses, that means the distributive property, and we usually show that by putting the arrows to show that we're distributing it to each part of the parenthesis. So what this would look like is 5 times x is 5x, and 5 times negative 10 would be negative 50. And I would go ahead and do the same thing to the other side of this equation. I would distribute now the 10. So I'd really like you to go through these problems. They are challenging. They're absolutely challenging, especially when you get down to numbers 8 and 9. There's a lot going on. At 9, you'll notice that there's brackets. So you always start with the innermost parenthesis. So here, there's really a minus 1. So it might help if you draw the 1 in. and you're going to distribute the -1 to both components, and you have to do one piece at a time. Then, once you're done cleaning that up, you're going to distribute this other -1 to all the components as well. So I'd like you to take your time and practice through this page. You can go to D2L to take a look at the answer key. There's a PDF file that shows all of my work because this is definitely a step-by-step process and it's going to take some time. When you're ready, we're going to move on to the next section of the notes. All right, so working with fractions can get a little tricky. The easiest thing that we're going to do is to get rid of the fractions. So we're going to get rid of the denominator. So in number 11, 3 and 6 are the denominators. So we're going to find their least common multiple, which we did in previous lessons. So the least common multiple of 3 and 6 is 6. So what we're going to do is multiply every single thing by 6 over 1. So I'm now going to distribute this to everything. So I'm going to have 6 times 5x is 30x. And then the denominator, 1 times 6 is 6. And we'll work on reducing that in just a moment. Bring my plus sign. And now 6 times 4x is 24x. And 1 times 3 is 3. And then finally, 6 times 13. Well, I know 6 times 3 is 18 and carry the 1. So 6 times 1 plus 1 more is 7. So now I'm going to be able to reduce these fractions. So 30 divided by 6 is actually 5. So this reduces to just 5x. And the next one, 24 divided by 3 is 8. So this reduces to 8x. And together that equals 78. So now this is a normal equation. We have two variables and they're on the same side, so we're going to combine like terms. So 5x plus 8x is 13x, which equals 78. And then our final step, we're going to divide both sides by 13. So our final answer is x equals 6. Once again, make sure we're organizing our work. I'm circling my final answer. So the next problem, I'm going to get you started on it, then I'd like you to give it a shot. So 3 and 8. So if I count by threes, 3, 6, 9, 12, 15, 18, 21, 24, that's the first time it's a multiple of 8. So I'm going to multiply everything by 24 over 1. So I'd like you to pause the video and then come back when you've done solving this and you'll be able to see my work. All right, take a look at my work for number 12. I had to distribute the 24. And then I simplified. If you noticed in the first part, I kept the numerator in parentheses so that I could eliminate the fraction by doing 24 divided by 3 is 8. Now, once I got my new equation here, I went through and solved it, and it does end up equaling 0. So you would, once again, make sure you distribute your 8 across, and then you would combine like terms. And to see the full results, you can take a look at the answer key available on D2L. And you have one more example to try, number 13. Practice with fractions. It does get a little tricky, so the more you practice, the easier this will become. Solving equations with decimals is the same thing as we normally would do. There's a couple strategies out there, but in my opinion, it's easier just to work with the decimals as they are. So for these examples, 14 and 15, I would solve them just as normal. Use the decimal. We have the access to our calculator, and you will on the test as well. So we're on to one of our last sections for this video. So when we're solving equations, they have three outcomes. It could be a contradiction, which means the answer doesn't make sense. So you keep solving and then you get some weird answer like 10 equals 13. And the variable just appeared and it just contradicts itself. Conditional is what we're used to. We have a solution such as x equals 10. And identity is when we're solving and it equals itself, such as 10 equals 10 or 1x equals 1x, 0 equals 0. It's not really a solution that we're used to. So there's a YouTube video that you're welcome to watch here, but I'm going to go through this. I think this is pretty straightforward for you guys. So we're going to solve these just like we normally have. So for this first one, I'm going to draw my line. On the left side, combine like terms. Negative 3x plus 5x is 2x. And over on the right, I need to distribute. So I have 2x. And then 2 times negative 2 is negative 4. And then bring down my minus 13. There's nothing really to do on the left-hand side just yet. I still need to combine like terms on the right, so I'm just going to bring down my 2x minus 5. And now over here, minus 4 minus 13 means negative 4 minus 13 more is negative 17. Now we can actually stop right here because we know that 2x's are going to cancel out. And we're going to be left with negative 5 and negative 17. That is not equal to each other. So this would be an example of a contradiction. All right, on the next page, you have a couple more practice of solving equations I'd like you to take a look at. And you're going to tell me if it's going to be a contradiction, a conditional solution, or it's going to be the identity. Now, this last section, I'm actually going to direct you to your D2L. So I'm going to jump over to D2L, and I'm in the chapter 5 and 7 folder. And this is about today's lesson, 7.1 and 7.2. It goes through what will be taking place, and I have posted tons of practice and YouTube videos for resources, but I really want you to take a look at the solving literal equations. These three are going to be your go-to. I've put the time lanes of each one. This is something I would really like you to go through in order to learn this topic. They do a phenomenal job. They start with an easy, they go to a little harder, and then finally the hardest types of problems you're going to go over. Obviously, I have my answers and my answer key as well. And there's a couple quizzy practices that you're welcome to do. So just like normal, you can click here to see the answer key for everything I just went over today. And this goes down to the conditional and identity in the literal equations that you'll see. Now the applications, and that's the last little section on your notes. I really would like you to try to reason through these. There are a lot of different ways to determine these. I will be posting another little helpful hints later this week if you're still struggling after looking at the resources I've provided to you. These are just good practice problems. I will be uploading this video for you, and you should be in good shape now to complete your 7.1 and 7.2 homework. Please make sure you reach out if you have any questions.